Today we are going to deal with module 4 of subject CS308 Software Engineering and Project Management for the 6th semester students, BTech students of Kerala Technological University. And this lecture is regarding coding and testing. Mainly through this lecture we focus on coding, and the lecture is delivered by Dr. Varghese S Chooralil, Assistant Professor, Department of Computer Science and Engineering, Rajagiri School of Engineering and Technology. Module 4 mainly consists of main concepts like coding and testing. Coding, it includes programming practice, verification, size measures of program or sizing measures of program, complexity analysis, and coding standards. Different phases in software development are requirement analysis, planning, design, coding, testing, and maintenance. Out of these main phases, we covered phases requirement analysis, planning, and design in module 1, 2, and 3 respectively. And in this present module, we are going to deal with coding and testing. Coding means actual programming itself. What do you mean by programming? Programming is the work output of the programmer, and where the programmer is applying his work output, it is done on the design. Therefore, programming is done on the design. During the coding phase, different modules are identified in the design document. Different modules will have different purposes, or each module will be done for a specific purpose. And according to the module division, respective programming will be done based upon the specification. The objective of the coding phase is to transform the design of the system as given by its module specification into a more higher level language code, and to unit test this code. That is actually what is meant by coding or programming. Once again I repeat, the coding is done on the design. The design is developed in the earlier phase. In the design, different modules will be there, module wise split up will be there, and in this module wise split up, the programmer will be giving his work output, or the programmer will be doing the coding on the design. Therefore, we want to consider some of the best practices which is followed in the industry for better programming. Therefore, whatever is followed in the industry to make a program better or good is considered as good programming practices. Therefore, different programming languages will have different practices or different good practices, but more or less these practices remain same for almost all programming languages. And when we follow this programming practice or good programming practice, it is easier for the company people, or it is easy for the management to maintain that code for a longer period of time. How it is maintainable for a longer period of time is the another question. As per the rule we are programming, as per the better programming recommendations we are programming. Therefore, when we follow this recommendation, these practices, the programs which is done by a set of people, a program or a product which is developed by a group of people will almost have a same mode of development of the program. Therefore, whenever one person or a set of people or a set of programmers leave the company for any reason, it is not a tedious job for the management people in order to deploy new people and make them cope up with the existing live project. Therefore, in order to make this mechanism means programming practices in a better way, the industry is following standards like top-down and bottom-up approach of programming, and this concept we have covered in earlier module. Next concept is structured programming, or we can mention it like it is go-to less programming. When go-tos are more used in the program, usually the complexity of the program may go high. Next is information hiding. Information hiding means hiding details of an object or a function, or we can mention it is mentioning only details that is relevant. The process of hiding details of an object or a function. Next is naming convention. Naming convention is a set of rules for choosing the character sequence to be used for identifiers which denote variables, types, functions, and other entities in the source code and documentation. Next method or next best practice is control constructs, and this control constructs mentions which way program control flows and use go-to statements sparingly. More the number of go-to statements, more the complexity of the program. User-defined data types or user-defined types allows programmers to define their identifier that would represent an existing data type. Another strategy is avoiding nesting and avoiding deep nesting, which makes code very difficult to read and modify. Deep nesting module function size, or the function size should be between 5 and 50 lines of code. Program layout should be with more indentation, blank spaces, parentheses, etc. Therefore, coding is done adhering to the coding standard applicable for the language. Continuing with the best programming practice, it's regarding internal documentation. Code or program or lines of code should be documented in the form of comments and prologues. Comments should explain what a block of code contains. Again, I repeat, comments should explain, or comments regarding a set of lines of code should explain what a block of code does and not how it is done. Commented code should be removed and give a block of comments, and it is called by a name called prologue, at the header of each module. And this header may contain the following information, like what is the module name, module description or functionality or what it does, parameters, their type, input, outputs, and data types and the purpose of data types. Assumptions about the inputs, side effects, global variables, modified database tables accessed with that set of lines of code, name of the author who has done the actual program or actual lines of code, date of creation of that particular program, last date of modification of that program, name of the programmer who made the last modification with date, any assumptions about the inputs, again name of the author, date of creation, last date of modification, name of the programmer who made the last modification I mentioned earlier, that should be done. In programming, size is important. Size means how you are going to quantify the program. Therefore, this quantification process happens with kilo lines of code, KLOC, is one of the methods. It means kilo lines of code, or KLOC measures the physical size of the code. Another sizing measure is function point, FP. Another is use case point, UCP, and another is object point. And function point, use case point, object point are units of measurement to express the business functionality, and which are logical measures. This function point, use case point, object point, etc. are considered as the logical measures in order to measure the size. But when we compare this function point, use case point with object point with the KLOC, KLOC can be counted only after development, or KLOC can be measured only after the development or actual programming is done. Whereas other sizing measures which I mentioned can be done in an earlier stage, which will be estimated from the software requirements. Therefore, this requirement I mentioned, it is the phase number 1 of the different phases of software development. KLOC depends on the programming language and also on the programmer. Different programming languages for actual programming will use or will take different sizes, or I would like to represent it in another method. For example, if you take two programming languages, Java and Python, this which is, if we are using these two languages for a common purpose, programming language number 1, Java, may take more lines of code than programming language number 2 mentioned as Python in order to complete the same task or the same job. The mentioned situation is also applicable for different programmers. Programmer number 1 is able to complete a job within 50 lines of code, but the programmer number 2 is able to complete the same purpose with 75 or 100 lines of code. That means kilo lines of code may vary for programming language, and also it is also dependent on the programmer's logical skill. Whereas other size measures are independent of programming language and programmer. Size measures other than KLOC depends upon software requirements only. Next is code verification. The purpose of code verification is to show that the code is consistent with the design. Code verification mainly falls in two categories: static verification and dynamic verification. Both are complementary in nature. But the type of defects which is found through static verification is entirely different from the type of defects which is found through dynamic verification. Static verification is more cost effective compared to the dynamic verification. Static verification is done through code reading, or mentioned as desk review. It mentions how to read and understand a program. This code reading. Code review or code inspection or peer review is the systematic examination to find errors. It is a systematic examination. Whereas code reading, it is mentioning about how to read and understand a program. In code review, we are going through the systematic method and finding errors. Code walkthrough is entirely different from code reading and code review. In code walkthrough, programmer leads other team members to go through the code and allows to ask questions. Therefore, he is giving the fellow team members the freedom to judge and ask doubts regarding his program. Depending upon the feedback, corrections are made. Static verification is Actually, the checking the software meets requirements before it runs the code. It is done manually. Manually checking the code happens, or manually program checking is happening, and assure the software satisfies all the expected requirements. And without code execution, find errors in early stages. Therefore, actual programming execution is not required in static verification. But in dynamic verification, actual program execution is required there in order to find the errors. Therefore, as it is happening without program execution, the errors can be corrected with the programmer's knowledge, with his fellow team members' knowledge, etc. And find the location of the error directly. Therefore, it is also less costlier compared to dynamic verification. Where we come to, or when we come to dynamic verification, it is purely based upon experimentation. It is purely based upon runtime execution. Not as we mentioned in the earlier stage, whereas static verification, where your knowledge, your colleagues' knowledge, your peers' knowledge, that doesn't matter here more. Here it is done with the code execution and checks the fundamental behavior of the software system. What are the fundamentals of a software system for running a product or for making a product? It consumes memory. It consumes your CPU's storage, CPU performance, overall performance. And so the name is dynamic. Therefore, there are a lot of other factors like your memory, CPU usage, overall performance of your computer when the computer is loaded up with the software. So it is purely dynamic and detects the presence of an error, but further debugging required to find the actual location of the error. Dynamic verification, again I repeat, dynamic verification will help you to find the error, but if you, where the error, what is the location of the error, you need further debugging methods in order to find the actual location. As it is completely based upon experimentation, therefore you need simulation tools, you need more integrated tools in order to run the actual coded program, and you need performance of the computer, memory, CPU usage, overall performance. Sometimes you may be loading the contents over some cloud server, etc. This dynamic verification is more costlier compared to the static verification. Again, coming back to the code verification, static verification, what is meant by code reading or desk review? It checks the consistency of the code and design specification, compares the abstraction of a module with its specification. Code is read inside out by the developer himself with the lower level components and moves upward to get the abstraction of the module. And the abstraction of the module is then compared with the design specification. What is the design specification? The design specification is done earlier and it is, that stage is completely over. Therefore, we are making things, or we are promising things, or we are promising programs based upon the actual design. Code review or peer review. In static verification, it is done by the peer programmer after a module is successfully combined and all the syntax errors are eliminated. Checks for the presence of some common types of programming errors and to check whether the coding standards have been followed or strictly followed is a criteria here. Therefore, there is a checklist which is used in this static verification, code review or peer review methods. And this checklist is used by the peer reviewer to ensure the completeness of review. Therefore, if there are 10 items in the checklist, if your reviewing is based upon that checklist, the probability of that 10 errors will be limited in the actual program after the peer review process. Why is it so? The programmer or the peer reviewer will cross-check whether these conditions which is mentioned in the checklist is followed in the actual program. Errors found are recorded and given to the programmer of the code for correction. Therefore, you must consider this as an important point. The programmer do the program, and this program is given to the peer programmer considered by a name called peer reviewer. Errors found are here noted by the peer programmer or your colleague and revert back to you if you are the programmer for code correction, for program correction. And in code review or code inspection, some of the common classical programming errors detected during the code review are use of uninitialized variables, jumps into loops, non-terminating loops, incompatible assignments, array indices out of bounds, improper storage allocation and deallocation, mismatches between actual parameter and formal parameter in procedural function calls, use of incorrect logical operators or incorrect precedence among operators, improper modification of loop variables, comparison of equality of floating point values, etc. Static verification code walkthrough, and this is done for modules with complex logic and algorithms to find algorithmic and logical errors in the code, and it is usually done by a review team of few members, and code is given to the review team in advance. In advance means a couple of days before the actual walkthrough meeting. Each member selects some test cases and simulates the execution the code by hand. Members note down their findings and discuss those in walkthrough meeting. Because it is found earlier, 1 or 2 days before, and the discussion happens at the walkthrough meeting only. Author either gives clarification or accept the findings as defects and fix them. If the author have any justification for some errors which is pointed out by his fellow members, he can justify them. Otherwise, he will accept those errors as defects and he will try to recover those defects. Walkthrough can also be used for transferring the knowledge of the code from one programmer to another program. Therefore, it is mutually contributing for the programmer and for the review team. The knowledge of the programmer will be shared to the review team, and the review team's comments, suggestions, points will be shared as a knowledge to the programmer's uh, knowledge too. And this is the advantage here in code walkthrough. Now today's lecture regarding this programming is over. Thank you.